All right. Welcome, pop stars. Let us get popping. We're trying to prove two side lengths are congruent. So we should probably take an opportunity right now and decode that information. We make sure we have a clear understanding of what we're trying to accomplish to force RZ and YU are congruent. Here's why I said it that way. To prove RZ and YU are congruent directly is very tough. One, there's no measurements on this diagram. Number two, you're not given enough to use things that are familiar, like, say, Pythagorean theorem. So when I say decode, what I mean is, well, what do I have to prove that forces RZ and YU congruent? And in fact, we're kind of proving this kind of indirectly. Well, first, let's locate where those two things are. RZ is here, and YU is right here. So looking at these two things side by side, well, hopefully you guys are noticing they're involved in two triangles. So YU is part of this triangle, and well, let's go blue, and then RZ is actually part of this triangle. Well, then the decoding has to be, well, if I can prove the purple and blue triangles are congruent, then RZ and YU have to come along for the ride. So that's going to be our strategy. We're first going to prove triangles are congruent. We're going to use that information and the definition of what it means for triangles to be congruent to show that the actual thing that we wanted to prove is true. Capiche? And that's where you answer back. And let's get going to it. Now, in terms of planning for this proof of the two triangles, because as soon as we prove the two triangles, everything else is automatic, we're going to run into an issue. We have some information right off the bat that's going to be great. We have this side, we have this angle. What we don't have is something else. We need another side, we need another angle. Well, if we want the side, it's going to be the one we actually need to prove, so size out, I only hope there's angles. So I'm looking at angle 2 as our angle, as angle 2 to be our second angle. In the same way, for the other triangle, I'm looking at angle 1 to be our second angle. Now, immediately I see that the angles I have marked 3 and 4 are congruent, which would kind of force 1 and 2 to be congruent as well. This would be through a combination of linear pairs, supplementary, and then kind of working with that equation, which we'll see in the proof, but that's going to be our plan. We're going to use it, so the first and second piece of information are kind of given to us. But what we don't have is that third piece of information, which will be these two angles, 1 and 2. We're going to use 3 and 4 to generate them using a combination of linear pairs and supplementary and some algebra. But that's what we got going on. Right? Excuse me. So let us get going on this work. Whoa. Hey there, out of aspect. Okay, so this seems to be like a fairly direct kind of setup, so I'm going to kind of annotate what I want to do here just to make sure we're on the same page. So my goal right now is I'm going to try to prove that triangle SRZ is congruent to triangle TUY. And I'm going to accomplish that by using side angle angle, which I will set up in a flow style proof, mostly because I just like it. I saw a lot of people writing 2 columns, which I think is totally cool, just not my personal style. So let's see. So the side will be SR, and that'll be TU. So it'll be the left hand and right hand parts of the diagram. So it'll be these guys. Okay, and that is literally just given to us. For the angle in question, I have angle 6 and angle 5. Now we got to be careful here. I know the temptation is going to be just to say angle 5 is congruent to angle 6 because it's given, but it's not given to us. What's actually given, how it's actually shown, is angle 5 and 6 are right. So we actually have to algebraically progress to that given statement, and that's what a lot of people are frankly missing out on. Some people are just saying 5 and 6 are congruent to one another because they're given. They're not, and they're losing like literally 12 to 13 percentage points because of that little slip up. So what we're actually given is that 5 and 6 are right, so that's where we have to start. So angle 5, angle 6 are right angles, or I'm just going to say are right. Okay. Well, now we progress that information. If 5 and 6 happen to be right, that means that the measurement of angle 5 equals 90 degrees in the same way that the measurement of angle 6 equals 90 degrees. Again, we have to show progressively, using algebra as a base, why these angles must be congruent. So angle 5 equals 90, angle 6 equals 90. Well, if angle 5 and angle 6 both equal 90 degrees, we can definitely say that angle 5 is the same as the measure of angle 6. Okay. And then angle 5 is congruent to angle 5 is congruent to angle 6. Now the only thing this is missing to make this a full proof is some justifications, but we can go back and put those in right now. Angle 5 and angle 6 are right because it was given to us. Angle 5 is equal to 90, angle 6 is equal to 90 because of the definition of a right angle. Angle 5 is equal to angle 6 because we substituted. Angle 5 is congruent to angle 6 because of the definition of congruency. Okay. So that would give us our second angle. So well, it didn't quite work out the way I wanted. There we go. Okay, so SR and TU, the sides are given. The angles 5 and 6 are going to be congruent after we show kind of progressively using algebra why that's the case. The last angles 1 and 2 are going to actually be the worst part of this. The reason why is because, again, we have a lot of algebra to show. We just can't say, well, angle 1 is congruent to angle 2 because of linear pair postulate. That is actually a completely false statement. And I just want to take an opportunity to kind of write out what I'm seeing a lot in proof and why you guys are missing a ton of points. If you were to say angle 1 is congruent to angle 2, and then for the reason of the linear pair postulate, this is a complete mismatch of information. The linear pair postulate says verbatim that if angles form a line, then those angles are supplementary. It doesn't say they're congruent. It says they're supplementary. This congruency just cannot come directly from the linear pair postulate. Now, is this the idea that's going to drive angle 1 and angle 2 being congruent in this diagram? Yes, absolutely. But again, just like with a 90-degree angle, we have to kind of show a progression algebraically. Like, the logic is not something that can just remain in our heads. It has to be out on paper. That's the whole point. Until you can actually get it on paper, then you don't actually have anything to show. Let me demonstrate what I mean. So angle 1 and angle 2, we want to show are going to be congruent, but we have to progress there algebraically. We can't jump there directly. So let's start with relationships that we do know with the linear pair postulate. Well, angle 3 and angle 1 are supplementary. And I'm going to do some abbreviation because I'm running out of space. Angle 2 and angle 4 are supplementary. And then I can justify that by saying that's because of linear pair postulate. So I've shown that the angles clustered at Y and the angles clustered at Z are supplementary. Well, now I'm asking myself, what information do I know because they're supplementary? Well, as a direct result, that I know I can add the measures of angle 3 to the measure of angle 1 and get 180 degrees. And then the measurement of angle 2 plus the measure of angle 4 together, you get 180 degrees. And that's because the definition of supplementary. Like, the definition of supplementary tells us only one thing, and that's the only thing we can quote, which is if the angles are supplementary, I can add the measures together and get 180 degrees. In other words, definition of supplementary gets us an equation. Now, just like over here, we have to algebraically progress that equation. Okay, so allow me to please scoot my screen down a little bit. Alright, so if I know that 3 plus 1 is 180 and 2 plus 4 is 180, I know that the summations themselves have to be equivalent. So I can state directly that the measurement of angle 3 plus the measurement of angle 1 is equal to the measurement of angle 2 plus the measurement of angle 4. Okay. And that's just going to be substitution or transition. I choose to quote substitution here. The two are actually in this case indistinguishable. Our goal was to show that angle 1 and angle 2 are congruent. We're very close. I have the measurements on either side of an equal sign just with 3 and 4. I am told one thing that's given, which I'm going to kind of write a sidebar module right here. I know that angle 3 is congruent to angle 4, and that was given. And because I know it was given, measure of angle 3 is equal to the measure of angle 4 by the definition of congruency. Why that's important, why I kind of saved it to write it here, is because if I can now substitute 3 for 4 and create an equation that actually is solvable. So what I can tell directly from this is that the measure of angle 3, yes, I know my computer's getting bogged down, go away. Measure of angle 3 plus the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. So what I've done is substitute out this angle 4 for this angle 3 because of this statement. So that's going to be a substitution step as well. Womp. Okay, so we kind of combine the idea. This is where it comes from, so this kind of is involved as well. Now that I have an angle 3 on either side, I can subtract that part from both sides of the equation. So I'm left with just the measurement of angle 1 is equal to the measurement of angle 2. That's going to be subtraction. And then, of course, angle 1 is now congruent to angle 2 by the definition of congruency. Okay. So I have condition 1, condition 2, and way up here I have condition 3. Now if I combine all three of those conditions, loop. If I combine all three of those conditions, I actually have what I wanted in the first place, was a proof of those two triangles being congruent. Okay. So now that I've shown side angle angle, I can conclude that triangle SRZ is congruent to triangle TUY because of the side angle angle triangles congruency theorem. And because the two triangles are congruent, I can directly conclude that RZ is now congruent to YU. And that's going to become the definition of triangle congruence, or congruent triangles. So this was actually what we wanted. So to kind of get out of control, so let's kind of do a quick review of how we did this. We wanted to prove that RZ and YU, the bottoms of two triangles, were congruent. So to do that, we'd have to prove the triangles themselves are congruent. We accomplished that by using side angle angle. Side 1 was congruent to side 1 on this triangle. We concluded that the two right angles were congruent by progressing by using a little bit of algebra, just up to here. The last angle is actually the tough one. It wasn't directly stated. We were told that the two supplements were congruent, so we went about proving that the two angles were congruent, and we did that by again a progression of algebra. We showed the angle pairings at y and z were supplementary because of linear pairs. We used linear pairs to drive an equation to relate their measurements. We combined their measurements to get to 1 and 2 being together in the same measurement equality. Use substitution and some subtraction and definition of congruence to find our last angle. Now that we have an angle, a second angle, and a side, we know the triangles were congruent, and because the triangles were congruent, the sides were. So again, a good example of how a very simple idea can blow up pretty big in terms of proof. Again, I hope this helped. Hope you guys are studying hard, working hard. And definitely preparing yourself for a test we're having on Monday. So again, questions you have about this proof, which I'm just going to dub proof number 2, please post on Edmodo. I'm going to be monitoring that all weekend. Spread the word, make sure everyone kind of knows. If you have some friends who are going to slack off, get on their case. This is worth a lot. It's not an easy test, and you can definitely expect something like this to be on that test. All right, you guys have a good weekend. Study hard.